Hi to everyone, this is your Sankarappa sir. In today's class or in today's video, we will discuss about E-plane T junction, E-plane T or the E-plane T junction. So it is E-plane T junction. So this can be formed when a rectangular waveguide section is to be cut along the broader dimension and attaching one more waveguide into the section, it will form the E-plane T. Once again I will repeat. When a waveguide section is to be cut along the broader dimension of the rectangular waveguide and attaching another waveguide, we can form the E-plane T section or the E-plane T section. Now if you observe, it has three ports. Let it be, this is port 1 and this one is port 2 and this is the port 3. The attaching third port is also called side arm, or it may also called E-plane. It is the E-arm. So in this waveguide, the port 1 and 2 are called as the collinear ports and the port 3 is called as the side arm. It is a E-plane T. It may also called a voltage or series junction device. When power is fed at port 3 or when the power is to be combined at port 3, then it is called as the E-plane T junction. When T10 mode is made to propagate through the port 3, it will come out through the port 1 and port 2 with a phase shift of 180 degrees or out of phase. The electric field lines change their direction when they come out through the port 1 and port 2, hence it is called as the E-plane T. Any signal which is to be split between 1 and 2 or any two signals which are to be combined will be fed from port 3. And also the effective value of the power which is to be leaving from port 3 will be the phasor difference between the powers entering at port 1 and port 2. Port 3 is nothing but E-arm. That is, the effective value of the power leaving the E-arm will be the phasor difference of entry powers of port 1 and port 2. When the powers enters through the port 1 and port 2 in opposite direction, opposite phase, it will come out through the port 3 as the maximum energy. The maximum energy can be obtained when the powers are to be entering through the port 1 and port 2 in opposite phase. Now, this E-plane T is a 3-port junction device. Hence, its S matrix can be represented as S equal to S11, S12, S13, S21, S22, S23, S31, S32 and S33. It is a square matrix with an order of 3 by 3. Now these S coefficients or the S parameters can be determined by applying the properties of the S matrix. First one, by using the symmetric property, we have Sij equal to Sji. That is, S12 equal to S21, S13 equal to S31, S23 will be equal to S32 and S31 equal to S13 and other thing is S32 equal to S23. And next, this third port is perfectly matched to the junction. Therefore, S33 equal to 0. Port 3 is perfectly matched to the junction. Therefore, S33 equal to 0. And then, when the power is to be fed at port 3, it may comes out through the port 1 and port 2 with out of phase. That is S23 equal to minus S13. That is third one. When the power fed at port 3, it may comes out through the port 1 and port 2 with equal magnitude and out of phase. That is S23 equal to minus S13 minus S1. Now by substituting this in this equation 1, we can get the S matrix of this E-plane T junction as S equal to S11, S12, S13, S12, S22 minus S13, S13 minus S13 and 0. Now let you take the equation. Now there are 4 unknowns 1, 1, 1, 2, 1, 3 and 2, 2. These 4 unknowns can be determined by using unitary property. So now the unitary property S into S complex conjugate will be equal to I. Now by using this property, you can determine the unknown parameters or the unknown coefficients of S. It is S and this one is S complex conjugate will be equal to I. There are 4 unknowns S11, 12, 13 and S22, and these can be determined by using rows and column multiplication R1C1, R2C2, R3C3 and R3C1. Now from R1C1, it is R1 and it is C1. S11 into S11 complex conjugate plus S12 into S12 complex conjugate plus S13 into S13 complex conjugate will be equal to 1. So directly you can write it is modulus of S11 square plus modulus of 12 square plus modulus of S13 square equal to 1. Now let it be the equation 3. Now R2C2, it is modulus of 12 square plus modulus of 22 square plus modulus of 13 square will be equal to 1. It is equation number 4. And R3C1, it is a modulus of 13 square plus modulus of S13 square equal to 1. Let it be equation number 5. And R3C1, so it is R3C1. It is R3C1. It is S13 into S11 complex conjugate plus minus. So it is minus. It is S13 into S12 complex conjugate will be equal to 0. So let it be equation number 6. Now by solving equations 3, 4, 5 and 6, we can determine the unknown coefficients or the unknown parameters of S11, S12, S13 and S22. Now if you observe the equation 5, it is S13 square plus S13 square equal to 1. So which implies it is 2 into S13 square equal to 1. Otherwise it is S13 equal to 1 by root 2. S13 equal to 1 by root 2. So S13 equal to 1 by root 2. Now we substitute this S13 in equation 6. Now by substituting in equation 6, it is S13 into S11 complex conjugate minus S12 complex conjugate will be equal to 0. That means either S13 is 0 or this term is 0. S13 is not to be 0 because it is already derived as 1 by root. Therefore, S13 complex conjugate minus S12 complex conjugate equal to 0, which implies S11 equal to S12. S11 equal to S12. Now, by substituting this S13 and S11 and S12 in equations 3 and 4, we can determine the required parameters, the other unknown parameters. Now, by observing equations 3 and 4 or by equating 3 and 4, we can say that S11 equal to S22. From equations 3 and 4, S11 equal to S22. From equations 3 and 4. Now let us take the equation 3 and 4. By substituting all these, you can determine the value of the required parameters. Equation 3 implies it is modulus of S11 square plus modulus of S12. S12 is nothing but S11. It is modulus of S11 square plus modulus of S13. S13 equal to 1 by root 2. It is 1 by root 2 square will be equal to 1. So it implies it is 2 into modulus of S11 square will be equal to 1 minus 1 by 2 will be equal to 1 by 2. Otherwise, this S11 equal to or modulus of S11 square equal to 1 by 4. Otherwise, S11 equal to 1 by 2 and that will be equal to S22. S11 equal to S22. But S11 equal to S12 also. Therefore, S11 is determined, S12 is determined, S13 is determined and S22 also determined. Now, by substituting these in equation 2, we can get the S matrix of the E-plane T junction. Therefore, equation 2 implies S equal to 1 by 2, 1 by 2, 1 by root 2, S11, S12, S13 and etc. So, it is the S matrix of the E-plane T junction. Now, we can give the interrelation between the input and output by using this S matrix. So, now B equal to S into A, B equal to S into A, S into A. Now, by substituting, we can have B1, B2, B3 equal to, it is S into A1, A2, A3. Now, it is B1 equal to, it is 1 by 2 into A1 plus 1 by 2 into A2 plus 1 by root 2 into A3. B2 equal to, it is 1 by 2 into A1 plus 1 by 2 into A2 minus 1 by root 2 into A3 and B3 equal to 1 by root 2 into A1 minus 1 by root 2 into A2. Now, by giving the different powers at different ports, the values are by feeding the inputs at ports at different ports, we can get the outputs at different ports, outputs at port 1, port 2, port 3. So let us consider the first case, case 1. Let A1 equal to A2 will be equal to 0 and A3 is not equal to 0. That means power is to be fed at port 3, no power at port 1 and port 2. By substituting in these equations, let it be the continuous equations as 7, 8 and 9. By substituting in equations 7, 8, 9, we can have B1 equal to 1 by 2 into A1 0, A2 is 0, A3 you can have the value of 1 by root 2, 1 by root 2 into A3 and B2 equal to minus 1 by root 2 into A3 and B3 equal to 0. That means when the power fed at port 3 and no power at port 1 and port 2, it equally splits between 1 and 2 with a out of phase, with equal magnitude of outputs at port 1 and port 2, but out of phase, opposite phase, no output at port 3. Now, let us see the second case. That means A1 equal to A2 equal to A and A3 equal to 0. Means that an equal magnitude of inputs are to be given to the port 1 and port 2, no input at port 3. Now, by substituting in the equations, we can have B1 equal to 1 by 2 into A plus 1 by 2 into A, B2 equal to 1 by 2 into A plus 1 by 2 into A and B3 equal to 0. That means when equal amount of powers are to be given through the port 1 and port 2, it will result at port 1 and port 2, no power at port 3, no power at port 3. Similarly, by giving the different combinations of inputs, we can have the different combinations of the outputs at corresponding ports. So it's about E-plane T junction. E-plane T is a 3-port junction device. Hence, we can represent that with an order of 3 by 3 matrix, and their properties are to be determined by using the S matrix properties. And by after determining the S matrix, we are given some different cases when power is to be fed at port 3, no power at port 1 and port 2. That indicates an equal outputs at port 1 and port 2 with equal output and opposite phase. That means the E plane T can act as the 3 dB splitter, and then by giving the equal amounts at port 1 and port 2 and no input at port 3, we can have the outputs at port 1 and port 2 but no output at port 3. Thank you all for seeing my video. I am requesting you all subscribe my channel, share my channel and like my channel for more and more videos. My videos will be very much useful for the engineering students. Thank you all. Thank you.